This is chemistry, and this is chapter 1, Basic Concepts About Matter. With each of these chapters, be sure you go over to Blackboard and print those student notes. There's a set of these slides and a place for you to take some notes. And in each of these lessons, I'm going to include a couple of things for you. One thing I'm going to include is a chapter outline in the very first lesson. You can see there's 10 sections in this chapter, so that can kind of just get you oriented. Today, we're actually going to cover sections 1.1 through 1.3 in lesson 1. Each of these lessons will be less than an hour, but you will typically have 2 or 3 lessons each week. So it's a lot of material, particularly this first week, but the material is pretty straightforward. And so hopefully you'll hang in there with me. Also, I'll give you a set of learning objectives. This is your checklist to get ready for the test, to make sure you know what you need to know. And remember, you need to understand everything about these. So, for example, if I say define the term chemistry, not only do you need to be able to actually define it, but kind of apply it and know the nuances associated with it. So, for section 1.1 example, there are 3 learning objectives. These are the things you either need to know or be able to do to be successful on the material. And I'll include these with each lesson. Also, I'll include some vocabulary terms. These may or may not be new to you, but you'll notice as we go through the lecture that when we come across one of these terms, it will be highlighted in a different color. For example, jumping into section 1.1, we're going to start by defining chemistry. So you can see chemistry is a vocabulary term. It's in a different color for you here to kind of point that out. But let's look at that definition. So chemistry is a field of study that's concerned with the characteristics, the composition, and the transformations of matter. There's 3 things going on here that I want to look at. First, I want to talk about characteristics. So characteristics, another word for that would be properties. And that's what we're going to actually be talking about in this first chapter are the properties of matter. Its characteristics, ways we can describe it or classify it, okay? Later on, we'll be talking about the composition of matter. What makes up matter? We'll be talking about elements and putting together compounds or composing compounds. And so we'll be talking about the composition or what makes up matter. And then finally, in a few chapters, we'll be really focusing on the transformations that matter undergoes. We'll talk about it a little bit in this chapter when we talk about transformations between solids, liquids, and gases. But really, when we get to the heart of the matter, we're going to be talking about transformations that occur as a result of chemical reactions. And so that'll be later on in the semester. The other big thing here is that we're talking about characteristics, compositions, and transformations of matter. And so I want to really look at this term matter because you need to understand what makes matter and what doesn't. So if we're going to talk about matter, what is it exactly? Well, here's your definition for matter. Matter is anything that has mass and takes up or occupies space. So it has to have 2 characteristics to be matter. It has to have mass and it has to take up space. Now, mass is kind of a distinct term, and in chapter 2, we're going to talk about the difference between mass and weight. They are not the same thing, but for now, in your head, when you think about mass, you can think about heft or how heavy or light something is or its weight. Really, mass is just the amount of stuff in an object. So, in order to be matter, it has to be made of something that has some mass, okay? And it has to take up space. When we say take up space, there is a specific type of measurement that we use when we talk about taking up space. If I want to decide how much space something takes up, I will measure its volume. So go ahead and get used to that term. Volume is the amount of space something takes up. I can measure the volume of a liquid in a container. I can measure the volume that can be contained in a box. But volume is what we're talking about when we're talking about taking up space. So to be matter, it has to do these two things. So it may be helpful if I give you some examples. So let me do that. Matter, first of all, can be either a naturally occurring living or non living thing, or it can be synthetic. When I say synthetic, another way to express that is by saying it is man made. It's not naturally occurring, it's man made. That's what synthetic means. So let me give you some example. Um, if I want a naturally occurring living thing, that would be like plants or bacteria. They're naturally occurring, they're not man made, and they are living. But matter can also be naturally occurring non living, like soil or rocks or air. That's all naturally occurring, but it's a non living thing. It can also be something that's man made. A good example is something like plastics, which doesn't occur in nature. That's a synthetic product. You can see that that means that matter is pretty much anything that you come into contact with, and that is true. Almost everything is matter. Some people get a little confused though because of something that they can't see, like air. So sometimes I'll ask, is air matter? And people will say, no, I can't see it. It doesn't really weigh anything. It must not be matter. But that's not true. So let me show you why that's not true. And I'm going to put a little picture up here. Let's say that you have an empty balloon and you blow up that balloon. What happens? The balloon expands, right? Why does it do that? Well, you have pushed air into that balloon, and air takes up space. It occupies space, it has some volume. So that's one of the properties of matter. So we know air occupies space. That's why that balloon inflates. But does air have mass? Well, let's just say you had a bar that you had suspended on the end of the string, and that bar starts out to be balanced, okay? And on one end, you're going to hang this empty balloon, and on the other end, you're going to hang that balloon that you just blew up. And when you do that, that bar is going to tilt towards this full balloon. Why? Because it's heavier. That air that you put in there had some mass, and we can actually see that because that bar will tilt towards that heavier full balloon. So, air, even though we can't see it, has mass and it occupies space. So, it has to be matter. So don't get confused. You don't have to be able to see it necessarily for it to be matter. So then that brings up the question, if almost everything is matter, including some things we can't see, what in the world would not be matter? And the answer here is energy. Now, there are several forms of energy. There's heat energy, light energy, electricity. There are other forms of energy as well. But energy does not have mass and does not take up space, so it is not matter. And our universe is really only composed pretty much of those two things. It's either matter or it's energy. Okay? And so that gives you a really great idea about what matter is. Let's see what you know. Question 1. Which of the following is a characteristic of all types of matter? Go ahead and put your answer in for me. These are not graded, by the way, but they give me an idea about what you know or what I might need to focus on or reteach. And it lets me know that you've checked in and watched the lesson. Okay, so the answer is C. Let's look at naturally occurring. No, not all types of matter is naturally occurring. Remember, we can have synthetic or man made. Visible to the naked eye? No, matter doesn't have to be seen, like air was our example here, but C is true because matter has to have mass and take up space. So we know that C is true. Question number 2, which of the following is classified as matter? Go ahead and answer this one for me. So if you put aluminum foil, you are correct. Energy, remember, is not a type of matter. And a scientific theory is just kind of an idea in your head that certainly doesn't have mass, although it may take up some space in your head. It is not matter. But aluminum foil has mass, takes up space. It is certainly matter. All right, moving on to section 1.2. Now that we know what matter is, you need to be able to describe it. And one way we can do that is to classify it as being either a solid, a liquid, or a gas. So these are the three states of matter we're going to talk about. There's actually a fourth called plasma, but we're not going to go there in this course. But so these three states of matter, solid, liquid, or gas. Let's start by defining them, and then we're going to look at them a little closer to see what determines whether it's a solid, a liquid, or a gas. So we're going to start with a definition, and I'm just going to point out something before I explain it. This will help you on the test. Solids are definite, definite. Liquids are indefinite, definite. And gases are indefinite, indefinite. Okay? So just note that. Now let me explain it to you. Let's look at this solid. The example we have here is going to be this quarter, this solid quarter. This solid quarter has a definite shape. We can even identify this solid quarter is round, right? But it has a definite shape. We can put it down in that beaker. It's not going to take on the shape of that container because it's a solid. It's going to stay the shape it is, okay? So it has a definite shape. And it has a definite volume. Remember, the volume is the amount of space something occupies. We can measure volume. Now, it's kind of hard to measure the volume of a quarter because it has such an unusual shape. And in chapter 2, we will talk about how you measure the volume of irregularly shaped objects. But we could. We can measure its volume. So this quarter has a definite shape and a definite volume. And these two things make it a solid. Now let's look at a liquid in comparison, okay? So a liquid has an indefinite shape, meaning that right now it's in the shape of a cylinder because I've got it in a cylindrical container. We call that container a beaker, okay? But I could take this green liquid and I could pour it into a round fishbowl, and guess what? The liquid would be round, right? So the liquid itself does not have a definite shape. It is indefinitely shaped. It takes on the shape of its container, as opposed to that solid, which has a definite shape, okay? Now let's talk about its volume. Just like the solid, the liquid has a definite volume, meaning that we could calculate it or measure it. As a matter of fact, if you look at this green liquid in this beaker, there are some markings on the side of the beaker, and if we could turn that around and see those, we could measure exactly how many milliliters of liquid there are in this beaker. So it has a definite volume. It takes up a defined amount of space inside this beaker. All right, let's look at the gas. Indefinite, indefinite. First of all, it has an indefinite shape. What do I mean by that? Well, like the liquid, the gas is going to just fill up or take on the shape of the container that you put it in. For example, when I blow up that balloon that we mentioned in the previous slide, the air takes on the shape of the container it's in. It takes on the shape of the balloon. So it doesn't have its own shape, it takes on the shape of the container. So it has an indefinite shape. And liquids and gases are alike that way. But they're different in terms of volume. The liquid, we could actually measure its volume. The gas, you are unable to do that because gases will expand until they fill their containers. And let me show you what I mean. Let's just say I had a container with a lid on it so that my gas could not escape. And let's say in this first container, I put a liquid, and my liquid would just say come up to here in the container. And I can measure that, right? That has a definite volume. I could actually measure that volume. But for the gas, if I poured a gas into this container and put the lid on it, instead of those gas particles being confined to the bottom of this container where they can be measured, what they'll actually do is spread out to fill the whole container with some spaces in between them. So it's almost impossible. You can actually measure the volume of gas, but it's just not readily apparent because the gas will expand to whatever container size you have. Okay. So it has an indefinite volume here. So for gases, indefinite volume, indefinite shape. Now, when I ask you these questions on the test, I'm going to ask you to compare some of these. So not only will you need to know the definitions, but you need to know kind of how they're alike and how they're different in terms of shape and volume. So here's the big question then. Now that we know the definition of a solid, a liquid, and a gas, what determines whether it's a solid, a liquid, or a gas? Well, one of them is pretty obvious to you, and that's temperature. So I want to start with that one, and I'm going to change my pen color here just a minute. And let's say we have liquid water. First of all, we're going to use this formula a lot. So let me go ahead and give you the chemical formula for water. You may already know it, but it's H2O. Okay, so that's liquid water. But there is a solid form of water. Think about it for just a minute. What's the solid form of water called? It's called ice. Now it is still just H2O. So the chemical formula is not any different. It's just a solid instead of a liquid. So we call that ice. What is the gas form of water? What is the gas form of water? If you put water in a pot on a stove and you heat it up, what do you get? You get steam, right? That's our gas form of water. And what determines whether water is a liquid, a solid ice, or a steam as a gas? Well, if you said heat, you're right. Because what we can do is if we have solid ice, we can add heat to it and it becomes a liquid. And if we continue to add heat and bring it to a boiling point, then we get the gas form, right? So there are some things going on here, and I want to talk about those in terms of the particles in these substances. So let's look at our solid ice. The particles in a solid are really firmly packed together. That's why it maintains its solid shape. It has to do with how close those particles are in that substance. And we're talking about molecules or atoms here, which we'll define a little later. For now, let's just call them particles. But in a solid, they're really firmly packed together, kind of like if you and 12 friends are packed in a little bitty closet, right? You don't move around a lot. You stay kind of this one solid mass. Well, if we add a little bit of heat to these particles, what's actually happening is that heat is a form of energy, and that energy is absorbed by those particles as you start to heat it up. And these particles actually, when they absorb this energy, can't sit still and they begin to vibrate and bump against each other and move apart. And then what you end up with is a little bit of space between the particles because of the heat energy that has been absorbed that's causing these particles to begin to move. Just like if I gave you a Red Bull, you couldn't sit still, you'd have to move. Same kind of thing. They absorb this heat energy and they have to start moving around. But what that essentially does is it begins to create space between these particles. And that's what changes it into a liquid. And that's why liquids flow. It's because they have this space in between them that allow the particles to kind of slide past each other and move. And that's what gives liquid this property of being able to flow. Okay? Let's say we continue to add that heat and those particles continue to absorb that energy and they really start bouncing off of each other and they move further and further apart. And then you end up with a gas where the particles are really bouncing around in the container. They've absorbed all this energy. They're moving and they're bouncing off of each other and they're really far apart. And then you have the gas phase. So, really, we've talked about two things here that determine whether something is a solid, liquid, or gas. One of those things is how close together the particles are. All right. Another thing we've talked about is temperature. And really, temperature's effect on the particles. But if we add heat, we can make a solid move towards a gas state. And it doesn't just have to be water. Think about if you had a chunk of metal and you add heat to it, you could make it liquid metal, right? So heat will do that to anything. It'll change it from a solid to a liquid to a gas. If you take away heat, the opposite happens, right? If we have liquid water and we take away heat by putting it in our freezer, we'll get solid ice, okay? So heat energy moves everything towards the gas state, and removing heat or taking away energy moves it towards the solid state. But there is actually one more thing that can determine whether something is a solid, a liquid, or a gas, and that's pressure. And I'm going to show you what I mean by concentrating on the gas here. Let's just say, for example, that I put a lid on this container and that lid had a handle on it, and I was able to press that lid down so that I press down on these gas particles. And what I'm doing is I'm forcing all of these particles to end up at the bottom of the container. What's happening to them in relation to each other? They're getting closer together, right? I'm packing those particles closer together. What's that doing? It's making it more like a liquid. So if you pressurize a gas, you can make it more like a liquid. Here's kind of what that looks like. You see, we're pressing down, we're taking those particles, we're moving them closer together, and that pressure is causing those gas particles to change from a gas into the liquid state. Now, there's actually a really common example of this that you know, and that has to do with your favorite soft drink, whether that's a Coke or a Mountain Dew or whatever you like to drink that's carbonated. How do they get those bubbles in there? Because bubbles really indicate that there's a gas, right? Well, that's actually carbon dioxide gas. Carbon dioxide gas. I'll write that down for you. Carbon dioxide. We just call it carbonation, but it's carbon dioxide gas that is in your soft drink that causes those bubbles. Well, how do they get it in there? Right? Well, they get it in there by pressurizing it. So they push those gas particles together so that the gas actually turns into a liquid inside your Coke or inside your Mountain Dew. And when you take the lid off and you hear that whoosh sound, you have released the pressure. And when you release the pressure, those gas particles, that carbon dioxide gas, can come out of that liquid solution and turn back into a gas in the form of bubbles in your soft drink, right? And if you leave the lid off so that there's no pressure, eventually all of that carbon dioxide will turn back into a gas because it's no longer pressurized, and your Coke will go flat, right? So this is an example of how they can take carbon dioxide gas and actually turn it into a liquid and mix it with your soft drink. They do that by pressurizing it. All right. You've probably also heard of liquid nitrogen. Nitrogen happens to be a gas at room temperature. And to get it into a liquid, what do? They pressurize it in these big tanks and turn it into a liquid. Okay, so there you go. We have talked about solids, liquids, and gases, and we have said that there are three things that determine the state of matter. Its temperature can determine whether it's a solid, liquid, or gas. Pressure can determine whether it's a solid, liquid, or gas. And then we said how close those particles are together. So your book says the strength of forces holding its structural particles together. So really what that's saying is how close are the particles together, because they're going to be really close in a solid and really far apart in a gas, relatively speaking. Now, when we move on to some harder topics in chemistry, you'll find out that there are some forces, some some chemical attractions and forces that can hold those particles together that make things more likely to be a solid. And we'll talk about that. But for now, you can just think about it as how far apart or close together those particles are. So this is question 1. Go ahead and answer this for me. All right, so we said the physical states of matter are, of course, solids, liquids, and gases. Let's look at number 2. Which of the following is a characteristic of both liquids and gases? Go ahead and answer this one for me. All right, so liquids and gases both have an indefinite shape, right? Because they both take on the shape of their container. They don't really have a shape of their own. They become whatever shape of the container that you put them in. So they're the same that way, but they are different. Remember, gases are indefinite shape, indefinite volume. Liquids have an indefinite shape because they take on the shape of their containers, but they have a definite volume, right? They have a definite volume. You can measure their volume. They just don't have a definite shape. So they're different in terms of volume, but they are the same in terms of shape. They are both indefinite. How about this one? If I characterize something as completely fills its container, what am I describing here? Okay, I'm describing a gas. Why is this not a liquid? We said liquid takes on the shape of the container. That's true, but right now we're talking about filling the container. We're talking about a volume. And you'll remember I told you that liquid doesn't completely fill the container. It'll just come up to wherever the volume of the liquid is. But a gas will actually spread out to completely fill up that container. Okay, so the answer here is gas. All right, winding it up with 1.3. Let's talk about the properties of matter because now we've defined matter. We know what it is, and we've talked about the states of matter. And by the way, we can say states of matter or we can say phases of matter. They mean the same thing. States or phases, we're talking about is it a solid, liquid, or gas? Okay. But we also want to be able to describe it a little more. So we use properties to describe the characteristics of a substance. And we use those properties to identify it or give a description of it. Okay. And there are 2 types of properties we're going to be talking about. We're going to talk about physical properties and we're going to talk about chemical properties. So we're going to talk about physical versus chemical properties here. Let's start with physical properties. So physical properties are characteristics that we can observe and use to describe a substance, but in the process of having this physical property, the matter or the substance will not change. Its identity stays the same. That's a key, and it will make sense to you shortly. But when we're talking about a physical property, the substance that we're talking about stays the same. Its identity does not change. Let me give you an example. We can take ice and melt it, and it becomes water. But both ice and water are H2O. So the identity of it really hasn't changed. It looks a little bit different, but it's still just H2O, whether it's frozen H2O, which we call ice, or liquid H2O, which we call water. It doesn't matter, it's still the same substance. So we haven't changed the identity of the water, we've just changed its state. So state or phase state or physical state is a physical property. Okay, so here's some others. Color, luster. Luster just means is it shiny or not? And then phase state, when we talk about phase states, we're just talking about the state of matter. We're talking about is it a solid, a liquid, or gas. That's a physical property that we can use to describe it. Melting point or boiling point are physical properties. Hardness is a physical property. There's a lot more, and we're going to have a couple more slides with some different properties, physical properties, so you'll know them all in a moment. But these are some examples. In other words, we can look at an object, we can say it's red, it's not shiny, it's a solid, it melts at 100 degrees Celsius, it boils at 200 degrees Celsius, and it's not hard, it's brittle. Okay, so these are physical properties we can use to describe matter. As another example, let's see if we can describe gold. And in this description, I'll give you a couple of physical properties that we didn't mention. And remember, we're talking about physical properties here, not chemical properties. We'll talk about those in a minute. So another way we can describe this is its mass. So anytime you measure or weigh something, that's a physical property. So mass is a physical property. So is volume. It's a measurement we can take. Any kind of measurement is going to be a physical property. We mentioned state already. This is a solid. So that's another way we can describe it. Here's one we haven't mentioned, malleability. Malleability means can you bend it? Is it bendable or shapeable? And actually metals are really great for malleability. As a matter of fact, we use copper, which is a metal. We use copper wiring in most houses. Why? It's malleable and it conducts electricity, which is actually another physical property. Okay, so we can say whether it conducts electricity or not. Copper wiring is a great example of this, right? And it's a metal. And a lot of metals are malleable. As a matter of fact, that's why we make metal jewelry, because if you heat it up a little bit, you can bend it and shape it. Most metals are also good conductors, but some things are not, like rubber, for example. They're not good electrical conductors. So electrical conductivity is one way we can describe it. Luster, again, this is it shiny or not? And gold has luster, it is shiny. How about thermal conductivity? It's a little bit like electrical conductivity. Will it conduct heat? Some things absorb heat and some things conduct heat. If you buy a set of pans for your kitchen, you want them to be good thermal conductors because you want it to transfer that heat from the stove to your food. Melting point. We said melting point, boiling point are both physical properties. Here are some more. And we've mentioned some of these. How hard something is. Luster, is it shiny? We've mentioned color. What color is it? We've mentioned boiling point and melting point. Anything you measure is a physical property. So we can measure temperature, we can measure length, weight, size, mass, or volume. All of those are going to be physical properties we use to describe it. And just keep in mind, when we are observing these physical properties, the identity of the substance remains the same. For example, the state of matter is a physical property, but it doesn't matter whether it's solid, liquid, or gas, the substance remains the same, even though those states of matter change. Okay? All right, let's talk about chemical properties because that'll really help you to distinguish between these. So a chemical property is a characteristic, again, that we use to describe a substance. But this has to do with whether or not it will undergo a change to form a new substance. Remember, with physical property, we were saying the identity of the substance did not change, it stays the same. But a chemical property is a way we can describe a substance to talk about what kind of changes it might undergo. And the three I really want you to know here are, is it flammable? Will it decompose? And will it react? So these properties are flammability, decomposition, and reactivity. These are the three big ones. And so will whatever we're talking about, if it has the property of flammability, it means it will burn, right? If it has the property of decomposition, it means it will break down into something new, right? For example, leaves and insects decompose into something new. They form a new substance in the forest or in the woods. But rubber and plastic, those don't decompose, right? So they don't have that chemical property. Will it react with something in like a chemical reaction, for example? This is a chemical property that we would use to describe something. And so we might say something will react with water or won't react with water. That is a way we describe its chemical properties. Let's look at some more. Now, the ones I mentioned are on here. So flammability and reactivity. So will it burn? Will it react with something? And then the one that's not on here is decomposition, but that is a chemical property. But there are some others here. Some of them you're not going to understand yet because they actually have to do with reacting. So enthalpy of formation, chemical bonds, coordination number, chemical stability, oxidation states. These all have to do with reaction. So these are not going to be on your test. If that helps you, you just don't understand these yet. Another one you might see though would be toxicity. Toxicity is a chemical property, whether something is toxic or not. Now, every substance that's out there has some physical properties and has some chemical properties. So I want to just give you an example of a substance and talk about both its physical properties and chemical properties to show you what I mean. So let's talk about copper. You've probably seen a penny. Pennies used to be made of pure copper. And as you know, they're kind of this orangey brown color, right? That's a copper color. And if we were to describe this with physical properties, we can look at our Statue of Liberty, which, by the way, when we first received her, she's made of copper and she was this color. She was this copper color. So we could describe her. We could say her color is this orangish brown. Copper's a metal, so it's pretty hard. It melts at a certain temperature. These are all, it's a solid, right? These are all physical properties of copper. It's orange, it's hard, it melts at a certain temperature, and it's a solid at room temperature. So these are physical properties of copper. All right. Now, we know that she's not still this color, right? So she sits in New York Harbor, and if you've ever seen her, she's this green color. What's up with that, right? Because she started out, she's made of copper. Well, it's because of one of her chemical properties. One of the chemical properties of copper is that if you expose it to air, it will form a new substance. And remember, that's the thing about chemical properties, is it has to do with the formation of a new substance. So copper has a symbol Cu. So Cu represents copper. By itself, it's this orangey brown color. But when it reacts with air, and in particular the oxygen in our air, it turns into something called copper oxide. Copper oxide. And copper and copper oxide are two different substances, so they have completely different properties. Copper is this brown orange color, and copper oxide happens to be this green color. So the Statue of Liberty changed from brown to green because she reacted with the air, and reactivity is a chemical property. So if I wanted to list physical properties of copper, I would say it's a metal, it's hard, it's solid at room temperature, it has a brown color. If I wanted to list a chemical property of copper, I would say it reacts with oxygen in the air to form this copper oxide. Okay? So that's a good example. Let's see what you know. Which of the following statements concerns the properties of matter? Which of the following statements concerning the properties of matter is false? Go ahead and answer this one. All right, so D is false. One example of a physical property of water is that it can be broken down into hydrogen and oxygen gas. This is false, and it lies in this broken down. Another way to say broken down is decomposes. And remember, decomposition is a chemical property. So it is false. This is not which of the statements concerning the properties of matter is false. One example of a physical property is that it decomposes. Decomposition is a chemical property, not a physical property. Okay. Another way we know that this is not a physical property is because when water breaks down, when H2O, which is water, decomposes, it forms new substances. It forms hydrogen and it forms oxygen. And this hydrogen and this oxygen have completely different properties from this initial water. Water is a liquid, these are both gases. Water is not flammable, hydrogen is flammable. So if we look at that decomposition that has occurred, we know we have formed new substances. And when you form new substances, that's a chemical change that's going on there. Let's look at the others and make sure that they are true, right? Because we found the false one. Properties of matter are two types, either physical or chemical. That is true. A physical property is a characteristic of matter that can be observed without changing its basic identity. Remember, physical property, no change without changing. Physical property, no change happens. A chemical property describes the way matter undergoes or resists a change to form a new substance. And that's the key with a chemical property. We form a new substance. So these are all true. All right, let's look at the next one. Classify each of the following properties of metals as a physical or chemical property. So it's going to give you a property, list it as physical or chemical. All right. So the first one said iron rust in the atmosphere of moist air. The fact that it changes from that silvery color of iron to that red rusty color should let you know that probably a change has taken place here. So this is a chemical reaction that has occurred. Rust interacts or has an interaction with moisture in the air. So that's a interaction is another way to say reaction. And we know reactivity is a chemical change. But the key here is that we have produced this new substance, which is rust. All right. The next one was mercury metal is liquid at room temperature. Remember, whether something is a solid, a liquid, or a gas is just a physical property. We haven't produced a different substance. Mercury is mercury, whether it's liquid mercury or solid mercury. So we have not produced a new substance here. This is a physical change or a physical property. The next one said nickel metal dissolves in acid to produce a light green solution. This is a little tricky because it used the word dissolves, and I'm going to make a note over here. You write it down. We're going to talk about it again in subsequent lessons. But dissolving is actually a physical property. It's a physical property. So why then did they list this as a chemical change? Well, it's because your book has some things that I don't love about it. And instead of saying nickel metal dissolves in an acid to produce a light green solution, they really should have said nickel metal reacts with an acid to produce a light green solution, because this is what's going on here is that you're producing a new substance, and that's why we have the color change, kind of like copper changing to green indicates a chemical reaction has occurred, and iron rusting illustrates a chemical reaction. This nickel metal changing from a metal color to a green substance indicates that there's probably a reaction that's going on here. Okay, so the color change indicates that there's a new substance, but this one is tricky. Your book really should have said nickel metal reacts with acid, and that would have kind of given it away because reactivity is a chemical property. All right, the last one was potassium metal has a melting point of 63 degrees. Melting point, boiling point, all physical properties. Okay. All right. Number 3, which of the following statements about various substances describes a physical property of a substance? So you're looking for the physical property. Go ahead and answer this one. Okay, you should have picked A. Copper metal can be drawn into a thin wire. Remember, the key here is if it's a physical property, then when we're describing it, this substance is not going to undergo a change to a new substance. So we can take copper metal and heat it up and kind of draw it out into really thin wires, but it's still just copper metal. So nothing has changed here. This is a physical property. Gold metal does not tarnish in air. When we talk about whether or not something rusts or tarnishes or burns, we're talking about chemical properties there, okay? So what this is really saying is gold metal does not react with air. And reactivity, this tarnish is reacting with air, and reactivity is a chemical property, right? All right, look at the last one. C, hydrogen peroxide decomposes in the presence of light. There's that decomposes. Decomposes is also a chemical property. All right, number 4, which of the following statements about various substances describes a chemical property of a substance? So in this one, we're looking for the chemical property. Go ahead and mark your answer. All right, and A should be your answer here. And again, your book does a poor job of this because just so you know, again, dissolving is a physical property. They should not have used the word dissolved. And the key here is they're putting it in an acid. What they're really saying is silver metal will not react with hydrochloric acid, okay? And I won't do this to you on the test. I'll be really clear. But I wanted to point this out because these did come from your book. So I want to point out this little bit of a discrepancy. So silver metal will not react with hydrochloric acid. Okay. So when it says dissolve, it means this acid eats away at this metal. This is really a reaction they're talking about here. This is definitely a chemical property. But let's talk about why these other 2 choices we know would not be correct. So beryllium metal has a silvery gray color, which we're just describing its color. It's a physical property. And ice melts at 32 degrees Fahrenheit, melting and boiling, again, just physical properties. All right, question 5. Which of the following pairs are both physical properties? So it gave you 2. They both have to be chemical. Physical. So let me list the chemical, and that way we know if we see one, we can mark it out. So flammability, reactivity, decomposition, and then we added one on one of those slides we talked about toxicity. And these are all chemical properties. All right. So density. Density is not one we've talked about, but you actually measure density. And remember I said anything you measure is a physical property. So this one's physical, but flammability is chemical. So both of the pairs are not physical. They have to both be physical. All right, let's look at the next one. Reacts with oxygen. There's our reactivity. That's chemical. And does not react with iodine. Reactivity. That's chemical. All right, very brittle. Brittle means it'll crumble or break apart. This is kind of like part of describing its hardness. So this is definitely a physical property. And then toxic, that's a chemical property. So you can see we don't have anything here that has both physical properties. So our answer here is no correct answer. All right, that's the end of lesson 1, and we'll pick up with lesson 2 in the next video. Hope you guys are having a great week, and if you have any questions, as always, just let me know.